Alright, so we're going to go ahead and do this because it's late, I'm tired, and hopefully we do this in one go and nothing breaks. So we're here today to solve a classic physics problem by no other than Brian Simpson. He gives us excellent accreditation, but let's move on. So we start off with little Timmy with a mass of 50 kilograms, accelerates from rest to a final velocity. That means zero velocity in the beginning, some, quantitative amount of velocity. Sure, why not? Sounds fancy. So he does this in a distance of 15 meters. His acceleration is due to a dog pulling a rope, which is attached to little Timmy. The dog pulls with a constant force of 400 newtons. Little Timmy experiences the force of friction on a flat surface with a coefficient of friction equal to 0.5. What is little Timmy's final velocity? So I like to start off things with what we know. We know that mu equals 0.5. We know that u, or initial velocity, equals 0. Acceleration equals question mark. Final velocity equals question mark. So we know what we're looking for. And now someone once great to me told me to always start with a free body diagram. So we're going to go ahead and do that now. This is going to be a little Timmy as a point, or a little black hole, whatever. We're going to start off with a downward force of mg. We're going to realize that he has a reaction force off the ground of r. Now, from a very nice story once told, apparently he is being pulled by a dog, which can pull with a strength of 400 newtons constantly. But he's also experiencing friction. So we're going to write that as mu r. And so, from there, we can start splitting things in components. So let's go ahead and do that. We're going to set up sum of the forces, Newton's second law, equals ma. We're going to do that for the y direction. Split it down the middle, and we're going to do sum of the forces. Sure, that's a squiggle. And the x equals ma. So we know that he is not going to be traveling up or down. We're also going to find our axes. We're going to go positive y, positive x. And so he doesn't travel up or down, so we know there must not be an acceleration up or down. You can go ahead and put that as 0. And so since the sum of Fy equals r minus mg, and since that equals 0, we can find r equals mg. R equals our mass, which I forgot to write down earlier. Mass of little Timmy equals 50 kilograms, times g, which we all know is 10. So r equals 500 newtons. Save that, we're going to use it later. So now let's go over to the x side. So we can see that sum of the forces is the dog. So F puffer minus, because it's heading in the negative direction, F friction. I'll use F of F from hereby. So equals ma. And so we know 400 newtons minus force of friction, which is mu r. We know mu, 0.5, and r. So that's going to give us 250 newtons from friction equals mass times acceleration. So 400 minus 250, class. Yep, you got it. 150. 150 newtons equals the mass of little Timmy, 50 kilograms, times the acceleration. And so we can do that quick math. 150 divided by 50. Class, Bueller? Yep. 3 meters per second squared equals a, the acceleration. Basic algebra, stuff like that. I grasp, but only sometimes. And so from then, we can use a nice little equation so pleasantly named Francine. So why don't we switch to a different color for that? Francine is, as it goes, v squared, final velocity squared. We're trying to find that, remember? Already found acceleration. 3 meters per second squared. equals initial u squared plus 2as. And so, let's think of what we have. We already have this, 0. We don't have this, that's going to be a big question mark. We have this, 3. And we have this. If you go back to the problem, distance of 15 meters. And so, why don't we put all this together? We get v squared, which we don't know, equals 0 squared plus 2 times acceleration, 3 meters per second squared, times the distance, 15, oh yeah, meters. And so, from that, we're going to go, not w, factor v squared equals 2 times 3, 6 times 15, that's 90. Look, I'll even do it for you. 6, 90. We're going to get, and that gives you 90 meters per second. But there's an issue here. We got to do the square root. So let's do that. We're going to do that, boom, that, boom. So class, what is the square root of 90? Of 90 equals, yep, that's right, some number that I didn't do yet. Let me pull out my calculator real quick. How about this? Hey Google. Hey Google. Okay Google. What's the square root of 90?
Square root 90 is approximately 9.487.
You heard that? Meters per second. And now, you don't tell me that internet never helped you learn anything, alright? Because look, we just solved this problem right here, and I even use Google to help me. You don't typically do that, but you do when you know how to calculator. Thanks for watching. Be sure to smash that like button and subscribe.